Hi everybody, and welcome to this panel session focusing on technology's role in helping the world to build back better for a sustainable and equitable future for all. My name's Fran Baker and I lead social impact and innovation at ARM, where we're looking to marry our business capabilities with our societal responsibilities. And I'm delighted to be part of this conference and especially delighted to be hosting this panel and welcoming you to this session. Today we'll be asking questions around the individual contributions that make up the technologies that we use and rely on in the world today, assessing how technology is interconnected and inextricably linked with the global challenges that we're facing, and asking the question whether technology is inherently good or bad or a reflection of those that shape it. We're asking you to consider the broader societal implications of technological advancement. And so today I'm delighted to be joined by our panelists, Melanie Smallman, Associate Professor in Science and Technology, a Fellow at the Alan Turing Institute and Co-Director of UCL's Responsible Research and Innovation Hub. Her research is looking at the social impacts of science and innovation and how this affects public attitudes. Shira Maina, a lecturer in electrical engineering at Dedan Kimathi University of Technology in Nyeri, Kenya, and he's also one of the organisers and co-founders of Data Science Africa, which is a grassroots organisation aimed at capacity building in the areas of data science and machine learning in Africa. And James Myers, a distinguished engineer at ARM Research, where he leads the Devices, Circuits and Systems Group. James is a chip designer with the remit to push ARM compute to the physical extremes. And so to begin our session today, I'd like to start with a question for Melanie, asking our panel title question: do you think that technology is the answer to build back better for a more sustainable and equitable future for all?
Yeah, hi everybody. I think that's a really great question. And I think for a very long time, we've thought that that is the case. And I think we need to be confident that technology definitely has the potential to tackle many of the problems ahead. And I think particularly around the theme of the conference relating to sustainability, where it's pretty clear that, decades of talk about behaviour change isn't really making the difference, and time is running out for tackling questions around climate change. And I think it's also pretty clear during this COVID crisis right now that so many people around the world are putting their hope and their trust in science to get us out of this situation, whether it's in the form of vaccines, better tests. So clearly there's massive confidence and hope that technology is going to solve lots of the problems ahead. But I think sort of alongside that, I think one of the things we need to be really conscious of is that technology rarely benefits everybody, or at least rarely benefits everybody in the same way. And for some groups, the downsides of the technologies are actually just as real and often more powerful than the upsides of it. And to me, I mean, from my research perspective, I think we need to sort of realise that in many of these cases, those downsides aren't just good technologies put to bad uses. The downsides are actually baked in to those technologies. There is no other way that they could exist in the world. And I think one concrete example that I've been looking at recently, and some colleagues of mine elsewhere have been looking at, is the impact of technology within healthcare. And in the UK, the move to use robotics within the NHS, and the sheer cost of the robotic machines, although the clinical benefits are still limited, the sheer cost of it is shaping the National Health Service in a particular way. It cannot be run on a local, diffuse level if we're investing in high technologies. The cost of it means we have to have a centralised healthcare. So a decision that's normally a democratic decision has been taken out of the hands of the people, and that decision to adopt high technologies within healthcare means that healthcare will take a particular shape that has benefits to some and disbenefits to others. So I think for me, one of the most important ways of thinking about this, if this is helpful, is rather than thinking about technologies as kind of solutions to problems or devices or products, understanding that they're much more powerful than that. They are shaping our world. So just as, if somebody was to say that a car is merely a vehicle from getting to A to B, I mean, that's not a good account of a car. You just have to look. I mean, I look out of my window here in London and you can see that my city and every city has been structured around that technology called the car. The decisions about where I live, where I work, who I'm friends with, all are based around the car. So it's so much more than a way of getting from A to B. And I think increasingly in the 21st century, we're going to have to think about digital and AI technologies in a very similar way, that these are the forces that are shaping our world in the 21st century. And that's the conversation that people want to have.
Yeah, that's a very interesting observation to see how technology is actually shaping the world around us. It's not just products or services or tools, but actually shaping the world that we live in. Do you think that there's a difference between the way in which technologists view technology, Shira, or compared to the general public?
Yeah, I think definitely as technologists, often my background is in electrical engineering, and often you abstract away the users and the individuals and are so focused on the tech that you can quickly just push things. You're interested in pushing boundaries further, making things faster, without necessarily thinking about how that technology is interfacing with the people who are actually going to use it. And there's always a danger of when technologies are being developed without the input of users. And for example, I'm not based in England, so I don't know about how the NHS is doing their implementing their robotics. But if these decisions are being made without the input of, for example, the healthcare workers, the community healthcare workers who are probably dealing with people on a more have an empathetic relationship to the healthcare recipient, so to speak. That's when I think tech can be dangerous, because it can actually, for example, you may want to do a healthcare intervention, and if you're just now using robotics in a way that doesn't take into account the interactions with the human being that help healing, for example, or have absolutely no idea that that is actually an element that enhances healing, then your technology can actually do more harm than good. So I think it's important to have a lot of voices around the table when people are developing tech, because we are just technologists. I think we need to remember that solving problems requires a lot of different areas of expertise.
Thanks, Shira. And James, do you have anything to add to that from a research perspective?
And from an arm perspective as well, I can't speak for all technologies and the good inherent goodness or badness of them, but I think, fair and equitable access to efficient and secure compute, is a worldwide good. It is on the needs hierarchy somewhere. It's above, water and electricity, but I think it is on there. And if you think about all of the things that's enabled, over the 50 years of Moore's law that we've enjoyed so far, in terms of the examples of transport and healthcare that were given, the robots of any form have been enabled by access to compute, high performance compute. These things are not offloading all of the control algorithms for the high power motors, that would mean they might kick somebody. That's all happening on devices. In terms of cars, electrification of vehicles, there's a lot of compute in electric cars, self-driving cars maybe someday. Micromobility, I'm really interested in that recently. That's being enabled by sort of smartphone platforms and online payment systems and things that couldn't happen without the availability of compute. And to Shira's point about who owns and designs these technologies or these products, again, I think ARM has been all about getting access to sort of low cost, efficient, secure compute technologies through our entire history, and you can see that pervading almost everything. So from a research perspective, my team is trying to push that further. We're working on higher performance where that makes sense, better efficiency where that makes sense, and maybe batteries are limiters, or battery life, or even batteryless if you're looking for very large deployments of IoT devices where you can't get out and service them and charge them and whatever. Some of the stuff we do in my team is to enable things that can't be done today, where there's a gap, ideally a sustainability gap or, an opportunity gap. We look at things like subsend printed electronics that can be made anywhere, not just in $1 billion fab, can be designed by anyone, using simpler design tools than a silicon chip that maybe has $1 million of EDA tools and $1 million of IP and $1 million of engineering going into that device. So we're trying to work on all of these fronts.
And are you seeing some of those innovations coming out in different places? Like you'd mentioned some of the boundaries that your team are pushing. It's also in terms of applications of existing technologies to new fields, for example, smart food packaging that you'd mentioned previously.
Yeah, so gas sensors, for example, then to draw on that. So gas sensors have been around for a while, but printed gas sensors, that's a new thing. They're not as good as the the large heated CMOS gas sensors that you find in particulate matter sensors, say, that are big and have a fan and a heater. They're not good, but we can pair them up with some sort of sympathetically fixed function printed machine learning. Very low end, just does one thing. In our example that we've worked on so far, it's telling you how bad your armpit smells. But all of that technology, the gas sensors, the classification, the sort of the hardware generation stuff, I think that will map directly onto things such as food freshness. There's a smell, you can, measure it, train it, you can give it a simple output of, is this thing safe to eat or not? So yeah, I think there's opportunities for all kinds of stuff.
Thanks, James. And I think we see these innovations playing out differently in different regions with different use cases or applications of technology dependent on who, where, or what they will be doing. How critical, Shira, do you think that technology needs to be designed either by or with the people that they're intended for? You touched on that briefly, but it'd be great to hear a bit more about how you see that playing out with your students at Dedek Kimathi or through Data Science Africa.
Yeah, thanks. I think it's absolutely critical that users' role in the of tech, and users in the more general sense here being, for example, if a technology is applied on the African continent, imperative that people who live the Africans are involved in the development of that tech. And so I'll just give a little bit about, because that's a central thesis of what we do at Data Science Africa, and also as my teaching in DCUT. And here the thing is, we all hear about artificial intelligence. We've just had an example of AI being applied in food packaging. And the thing that we are trying to do as African machine learning researchers, African engineers, is actually empower our students, our local communities to be taking advantage of these high technologies. And because it's important to also understand that not every problem needs high tech to find a solution. But I think it's important that as diverse a set of people have access to these technologies, everybody should have an opportunity to use them and use them to their ends. So, for example, an application in Kenya, we may not immediately think of packaging as the most important application on our end, but similar technologies could be used to solve problems in healthcare, for example. We have examples out of some labs affiliated to DSA where they're doing things like diagnosis of malaria using slides. And in our own lab, we are doing ecosystem monitoring, water system monitoring, and all this is employing technology that's developed outside Africa, but being repurposed for our own ends. And eventually, what would be ideal would be also new tech being developed of the continent. Because when you have free flow of information, flow of ideas, because we all live in different environments, face different challenges, and that impacts how we see things and the sort of solutions we come up with. So I think the future where more people are around the technology table is really good for everybody. And that's what we are really trying to do in Data Science Africa, and also ensuring that when we are training technologists, we are training them to understand how to work across disciplines. Because now the most interesting problems, for example, if you're talking about food freshness, just to leverage that example, if you're just developing it as an electrical engineer, you may not know what you need to look out for, right? So we need to train our technologists to work across disciplines, and also to really have empathy for how the users will interact with this tech. That's one of the key things I think that's important as we educate the next generation.
Absolutely, and embedding that kind of thinking from the very beginning, the foundational level, and also understanding that technology is not a silver bullet. It's not always the answer to challenges or particular solutions, but that actually it's an enabler, and having that diverse and inclusive representation when you're building, designing and engineering technology is crucial. Melanie, how have you seen that playing out in the UK, either in your role at UCL or through your Turing Fellowship, or do you have any other examples that you could nod to that bring this to life a bit more for the audience?
Yeah, I've got plenty of examples. I mean, I completely agree with what Shira's just saying. I think that it's just increasingly seen as good design to involve users in the process of doing that. I'm actually involved with the European project at the moment to develop methodologies for doing that. So I've been looking for case studies. And I think, the classic one, which my colleagues always talk about, again, is robotics. We're having a robot day with me. There was a group of engineers who were robotic engineers, and were really concerned. They'd heard a case, people who lost limbs, and they thought that the thing, it would be terrible if you lost your hand. They thought that would just be awful. Let's try and step in and develop a robotic hand that functions pretty much like a human hand, and that would really, really help those people who, for whatever reason, only have one hand. And they spent years and millions developing a robotic hand that was really finely articulating and could pick up pens and could sort through things. They gave it to children who, from families that couldn't ever afford this kind of technology themselves, and then watched the children use these. And what they found was that they were completely useless, these hands. What the kids were using instead. One child had a drain pipe, his what was left of his arms shoved in a drain pipe with a fishing rod glued on it, and then another day he'd take that off, and another day he'd have a fork glued onto it. And what the engineers hadn't understood is that actually one mobile hand is enough, as long as you've got something else which can grip things. And so this flimsy robotic hand, which could do fine-grained work, was completely hopeless if you just needed to hold a piece of meat firm on the plate and cut it with the other hand. So, this is the kind of classic story of how we can get well-intentioned things can go so wrong if you don't actually involve the user in the design process. And I think, just to add, that's one of the things that one of my jobs, so one of the things that I like doing is teaching this to engineering students at UCL. And one of the things, I hope none of my future students are are listening, because then I will have lost the game. But one of the things we do is, because UCL is situated right next to the British Museum, we go to the British Museum and look around one of the galleries. And I say to them, have a look around and come back to the classroom ready to describe to me the most useful object in the gallery. And they spend half an hour looking around, and I wait and I sit in the corner just in case there's any questions. And we get back to the classroom and they all describe what they think was the most useful object. And I say, well, isn't that interesting? Because I actually was thinking I wanted you to describe the most useful object for a child. But none of you actually asked me who it needed to be useful for. You just assumed that if it was useful for you, that was sufficient. And every year, I mean, I've been doing this for 10 years, every year they're like, why didn't we guess that? But it's a really important question to ask. Is useful for whom? And who gets to decide what's useful?
And who benefits from using it? I mean, you didn't want to be on the opposite side of one of the spears in the museum, for example.
Dead right.
Yes, that's a good. And do you have any other examples, Melanie, around how privacy and data might be a compromised issue if not considering design with the user?
I mean, I think one of the instances that my colleagues have been looking at, which kind of runs across both privacy and user design. So I have a group of colleagues who've been looking at smart hubs, you know, the devices that talk to you in the home and you can use to control your lights and so on. So first of all, the horror stories of, to me, they're horror stories. So the data from the light bulb, the smart light bulbs, even the developers don't know where it goes to. So the data in those light bulbs goes to about more than 10 different companies, and it's reached the point where hardly anyone knows who is getting all of that information. And it seems kind of a bit throwaway. Well, who cares when I'm turning my light on and off? But actually, that really is saying quite a lot about your lifestyle and when you're at home. I mean, in the olden days when we used to leave home, it told us a lot. Right now, it tells us nothing. But, you know, so questions about who gets hold of that data that's kind of embedded inside these devices. But I think more interestingly, the group of my colleagues have been looking at the effect of these Internet of Things home hubs on different groups. And what they found is that for women in coercive relationships, so often the victims of domestic violence, these are particularly troubling devices. And the reason they're troubling is that, first of all, the coercive partner can use it to control the home remotely. So they can turn the lights on, they can turn the heating off, you know, so they can freeze the woman in the house, they can even lock the doors, they can see who's coming. So this is quite a distressing thing. But even more troubling than that is the ambiguity that's built into these devices. So actually, they're not that interesting. They don't do that much. And when I don't know if anyone's got one, but I'm told that when you get one of these devices, there isn't an instruction manual which lists all of the things that they can do. The idea is that you get a device, and it's like getting to know a child or a new pet, that they grow with you as they learn your habits, and you get to explore their potential and their capability. If you don't know what a device is capable of doing, your coercive partner can tell you all sorts of things that the device can do. And my colleagues are reporting stories where, and it's usually women, have been told by their partners, the device is watching everything you do, and I've got it on my phone. I know who you speak to. I know how long you're spending doing housework. I know who comes to the door. Of course, these things aren't true, but that ambiguity that makes them delightful, charming, appealing devices is the quality that is making some women extremely vulnerable to have them in the house. So it's kind of, you know, that's kind of data tied in with, I mean, how could anyone expect that until it was put into use? But tied in with, you know, it's all of those issues around privacy and these qualities that are baked into the technology.
Yeah,
Melanie,
and I think
what's
that's a
your view
really
on the sort of
important point.
transparency and auditing
Transparency.
of software? I mean, is there a solution to that? I mean, I've heard algorithm audits proposed. You say it's a black box, and exactly right. Black boxes are bad. They're scary, open to abuse, as you say. So, is there any legislation option or oversight option
Well,
on the cards for that?
the problem is the coercive relationship in that instance, isn't it? I mean, I think
Yeah.
it's an extreme example, but you could see it. So when we saw the A-level debacle in the UK over the summer, where what did the Prime Minister called it, a rogue algorithm, but it was an algorithm doing exactly what it had been asked to do, but nobody quite anticipated the consequences. And in that instance, transparency clearly was necessary to figure out how this had gone wrong. But the thing that to me is kind of interesting but also perplexing about the home hubs example is that the lack of transparency is its selling point. I think if you knew the limited things it's capable of doing, you probably wouldn't buy it. So it's in the manufacturer's interest. They're selling a interesting, exploratory, you're going to go on a journey and learn it. That's what they're selling. So transparency would kind of kill the product in that instance.
Magical
I haven't
AI.
got one.
Yeah, but I think it makes a case for some sort of regulation, but also brings home the point that somebody developing the audio algorithms will be looking at it in a purely technical, from a purely technical perspective, and not even have the slightest idea of the potential for this sort of harm. And I think that means that really people have to almost always audit the products, even when in use. I think companies that are developing this sort of tech need to, the way you have software patches, you can have almost, is it fit for purpose? A fit for purpose update, to ensure you're not putting things out there which are actually doing a lot of harm to vulnerable groups.
Yeah, I think that's a really key point then, if we can imagine the future and invent technologies and be responsible for that, we also need to consider the unintended consequences. So I think it's a balance of the risks and the opportunities with technology, and to be considering that from a holistic perspective to be able to understand what those unintended consequences may be. I've just seen a question pop up whilst we've been talking around who's responsible for thinking about these issues. And Shira, you touched on it briefly there. Is it the tech companies? Is it the governments? Is it individual engineers? Where do the roles and responsibilities end? And I think as we're talking about it, we can just jump to that question quickly before I finish with our final one.
I think it's a societal thing. I think everyone has a role to play. So the tech companies need to be more open to the fact that it's not just about tech, it's about the users of the tech, and and they need to ensure that they have enough people around the table. So I hazard a guess that maybe the groups developing that tech are maybe not diverse enough, have no idea that there could be vulnerable women or vulnerable partners. Use that as an example. So opening up who's developing the tech, and also government being responsible enough to say need to keep an eye on what's being developed. I think and also consumer groups, because we're just imbibing all this tech. We need to look at how is it affecting family dynamics, how is it affecting other, the people in the society. I think we all have a role to play in making sure that tech is responsibly used and the unintended consequences are minimized while still allowing, innovation to proceed. It's a fine balance, but I think it has to be done.
So I agree, it's everybody's responsibility in the chain, but I guess I want to give another example of maybe smart cities which aren't owned by individuals. The sensors, they're there for, or going to be there hopefully for a really good reason of managing pollution, health, safety, efficiency of these big cities as more and more people come into them, and that's infrastructure owned by governments or government contractors. And still there, we can't have black boxes, I think. And I think there's two pieces here in making tech approachable. Maybe you can query a sensor somehow with your phone and say, sorry, with my research hat on, query a sensor, say, what are you doing? What known software packages or VMs are you running? Can I look those up in a database like you kind of do with rogue, processes on your laptop sometimes, that sort of thing. So there's potentially a tech piece there. There's a management piece there. But the reason for having that smart city technology is much more useful and serves sustainability more than some of the IoT pointless internet connected gadgets that we're sort of seeing today.
Yeah, I think the question is, really a key question, and thankfully one which isn't going to be settled for a while, because that's what me and my colleagues do our research about. And I think the assessment so far that everybody needs to be involved is dead right. And just one thing relevant to this audience to flag up is increasingly. So I largely teach students who are studying science and technology studies, but I also teach ethics and responsibility to engineering students. And part of the reason that I do that is that we recognise that increasingly tech companies are asking for engineers who are trained in ethics. And, their argument is, why are we paying these large salaries for people who can only do part of the job? They have to be involved in accounting for what they're doing, thinking about the ethics. And so that's one of the things we're doing at UCL, is helping train the engineers of the future to participate in this idea of responsibility, and play a fuller role, I hope.
Yeah, that's really important points, and I think everyone aligned on the fact that there needs to be a broader, more diverse representation in the design and implementation of technologies to ensure that it's future fit, so that it's not contributing to greater inequality or undermining the rights of people around the world, especially those who are disempowered. On to our final question for the panel before we jump onto the Q&As that I can see coming through. I want to touch on something that we're reading about a lot at the moment, these large-scale shifts towards waste reduction, trends around plastic pollution and circular business models, and the way in which businesses are adapting to changing consumer behaviour as millennials reach the height of their purchasing power, for example, and conscious consumption is moving from the periphery to the mainstream. James, I'd like to ask you, why is the shift towards circular absolutely necessary? And what are the current barriers that we need to solve to move from a take, make, dispose economic model to one that's regenerative by design, starting with research?
That's a great question. So we heard our excellent keynote earlier today, to introduce a bit of circular economy. And I really think it's non-negotiable. It's going to be mandatory going forwards. If you look at any of the data out there on the sort of yields of ore or the availability of lithium or recycling rates, they're all atrocious. I think there's one of them that surprised me, is that there's more gold in a smartphone by weight than in gold ore. And there's reams of these surprising statistics to draw on. So circularity, where you close the loop. You don't discard any resources, you don't sort of adulterate them irrecoverably, is really important. We need to be making best use of the resources we have available, enriching ourselves for good once we introduce something, and having as little leakage as possible out of these closed systems. Now, it's really hard, and I fall into the trap that was mentioned earlier as a technologist, as a chip designer, of saying, oh great, I can design some chips to help this fix. That's where the sort of smart packaging idea came from, or RFID perhaps for managing supply chain provenance, but also user usage of of an object, and then maybe smart recycling and rerouting the materials back to the original manufacturer for disassembly, refurbishment, or whatever. So I do think it hasn't been field tested or anything, but I think there's capabilities or niches where I can invent technologies and then we can test the fit for them with the people that know, the people that are really manufacturing or operating supply chains and so on. But electronics itself, isn't circular, so it is part of the problem. It may not be the biggest problem, but we need to sort this out too. Another statistic you can find out there: the UK generates 25 kilograms of electronic waste per person per year, which is it's a lot, right? And it's going up worldwide. Globally, only 20% of e-waste is recycled, and of that, what percentage of materials and components are recovered? The best in class sort of smartphone recycling recovery is about 30% by weight. Actually recovered, the bulk metals like copper, steel, aluminium, cobalt. So there are really, really hard places within this. The super efficient processors that are both fast, very efficient, very, very miniaturized. They have most of the periodic table mixed into those at this point. Given the sort of 50 years of R&D investment in Moore's law. But there are some areas where we can get started on today. If you think about extending device lifetimes, you should be able to repair them. So right to repair is a big movement now, and rightly so. Devices should be designed to be repaired and not, by a hyper-skilled person with exactly the right custom tools. More widely than that. When an online service is closed, that shouldn't brick working hardware. That's another thing we see, right? At a minimum, that hardware should be unlocked, made compliant with open source platforms maybe that are out there as well. You shouldn't get in the way of people trying to use that hardware. Security updates as well. The internet is still the Wild West. Security is an issue. There are a lot of software exploits, every day, every year, and so security patches on devices are really important. And if you cut those off after 2, 3, 4 years, again, you're effectively, relegating the users of that to an insecure world, and that's not right either. That is also leading to obsolescence and more e-waste. So those are things that, as an industry, we could start to try and address. Maybe there's regulation, there's educational pieces to this as well. But I think many of these are an artifact of economics. You're effectively selling a piece of hardware, bundling N years of software, service, security with that into the hardware price. And I think that's the problem. That's why, these things get cut off eventually, before their time. But there are business models that can promote much more circularity. You can lease light today. None of us need a light bulb, right? We buy a light bulb to plug it in, turn it on, and have light in our homes. Whether it's smart light bulb or not. Leasing light is much more of a long-term solution because the ownership of the light bulb is on someone else, the management of it, the optimization of the energy use. Taking it beyond 10 years to 11 to 12 will make a difference to them, to the designer, to the owner, and the service provider. So design criteria will be very different if we're moving to a lease model. We're exploring different business models here, and then there are research technologies that can play in there at the chip level. I can invent some new chip technologies that make it easier to maybe break up 3D chips. Maybe with wireless comms between them, so you just mix and match. You glue on a different, or tape on a different accelerator perhaps on your processor, or circuit boards that can be maybe dissolved, and that you reclaim the components, ideally with paper or biodegradable, components. And so there's a lot of stuff that's materials, chips, devices, services, and it'll require a lot of collaboration. Again, it's everyone's problem, but I'm keen to collaborate on this and try and figure out where we can help.
Thank you, James. Really interesting observations, and I think we've touched on a lot of multifaceted and interconnected challenges that tie together to form these wicked problems that are the global challenges that we're facing as a society. James, you've provided a few suggestions on things that the audience here today can participate in or start thinking about. I'd like to ask Melanie and Shira whether you have a message that you'd like to give to the audience today in relation to any of these topics that we've been talking about, starting with Melanie, please.
Yeah, I mean, I think just to keep it very brief, the thing that I sum up when I'm teaching our engineering students is, I think it's often the slogan that developers are often sold, or the idea of what our aspiration is to do the best science or develop the best technology in the world. But I actually think that the challenge for the 21st century is a bit different. It's not about doing the best science or developing the best technology in the world. It's about developing the best technology for the world. And I think that means really thinking a lot more differently about what your goals and what your objectives and what your motivations are in, even becoming a scientist or an engineer or a technology developer. Because James illustrated perfectly there how, these really pressing issues, science, technology and innovation can provide answers to it. We just need to be really focused on both the problem and the best way of solving those in a way that enhances democracy and humanity, rather than sets ourselves against one another. So that's my selling point, is let's all aim to do the best science and technology for the world.
Yeah, if I can just jump in there, I think to make things sustainable, they must be good for most of the people, if not everyone in the world. So I think our job should be to try and ensure that the tech we develop is accessible to more people, helps more people live better lives. And if it's not achieving that, then that's I think a key for us to relook at it, because we need to be looking at maybe more reuse of things instead of always, as technology is always reaching out to make things that are bigger, faster. We need to, are they better? I think we really need to make them better and better for people. And that will require us to really work across disciplines, across regions, and to just really look to doing what's really good for all on the planet, and that will be good for everyone.
Thanks very much, Shira. And we've had a number of questions coming through during this panel, and one that touches on what you've just mentioned there, Shira, on the problem that you described previously around technology being imported and not built locally. What do you think is needed, whether that's to do with education or regulation, to build technology ecosystems in different regions?
I think a lot of that is the different geographies requiring different technological solutions. A lot of the times it's imported because just because of the way the capital is. So a lot of countries in Africa, we are a market. It doesn't mean that you don't have indigenous technologies being developed to solve the local problems. But the advertising machinery is so large, there's a lot of pressure to import products and not develop them locally. So a lot of that has to do with geopolitics, I think. And it's not inherently that there is less education or less ability in some of the markets which are mainly importing. Sometimes it's just the decks are stacked against. So that's one of the problems. And I think I think sustainability will eventually force some of these things to change, because, for example, in the COVID crisis, when supply chains are disrupted, it forces us to focus really on what tech do we absolutely need. A lot of it should be locally developed, and I think this is emerging naturally from what we find, from the situations we find ourselves in.
Yeah, and a lot of that to do, like you mentioned, that it's not to do with a lack of interest, intention, education, or skills. It's to do with lack of access to knowledge, devices, data. The access challenge being the bigger one, and it's more about enabling those opportunities in different regions as opposed to the skill and the talent not being there, as you've shown through your students and through the Data Science Africa community. Another question that we've had is, what are the right feedback sources or channels for technologists to understand what are the appropriate technologies? Is there alternatives to market commercial success? Melanie, I think this one might be for you from a RRI.
Yeah, I'm just thinking how best to answer that. I mean, I think that's interesting question and quite a big challenge. And I think that there are tried and tested methods. I mean, one of the ones that we're working on at the moment is it's just using the design process that are used by designers and prototyping to see. At the moment, we're testing ways to open those processes up. So our answer is that we have to open up every step of the development chain to wider voices, and that means putting in extra time and resources to reach out to users, to people who may be affected and who are not users. Because remember, to go back to my car analogy, it's not just the person driving the car that's affected by the car. You have to cross the road in a particular place as a pedestrian because there are cars in the road. So I think just thinking about the different stakeholders and building in the opportunity to engage with them and talk the product through with them, to test it with them, even to involve them in what we call the ideation phase. So when you're even beginning to think, is technology the right solution to this problem, is involving the potential users and the potential stakeholders affected right at that earliest stage. And I think the thing that's becoming apparent to us through trialing this is that it costs time and it costs money, but it's nowhere near as expensive as getting it wrong. And so our argument throughout it is the cheapest way of getting a product and a policy. Actually, we're working with policymakers to trial this, not just in product development. Our argument is that the cheapest way of the cheapest product is the one you get right the first time. And this is what we're trying to make sure happens by opening up this process. So it is about listening, it's about involving people, and it's about engaging with the outside world.
Yeah, that's a really interesting point. If we are quick, we might have time for two more questions. Should we be advocating rollout of IoT given all the business, technical, sustainability challenges you mentioned, or hold off until more progress has been made?
I think, well, there are certain, I think you have to choose the problems right. I don't think you can ever get a technology right if you've not deployed it. So I think you need feedback from use. And I guess it goes back to the challenge of what's the appropriate feedback. But I think you really need to deploy things before you can actually say they work. So you correct them outside the use environment. I don't know. That's my opinion on that.
Yeah, I think I agree with that. It's really hard to talk about IoT as a single thing. It's so many different applications and so many different fields, and it's everything from big Linux computers, in a factory, through to tiny little sensors buried in the soil. So where the sustainability demands are there, like in reducing, improving crop yields and reducing over fertilization, overwatering and that kind of thing. Yes, we should be deploying stuff there. Is it 1 trillion devices that are all energy harvested? Probably not immediately. Likewise, smart cities, more and more people moving there. Like I said earlier, there's big health issues, there's traffic, there's congestion, there's COVID issues of spacing and concentration of people, and we shouldn't wait on those. but we should develop the right sort of things that have respect for privacy, have security, have energy efficient hardware in them, and last for a long time without bricking in themselves.
And to finish with a cautious note of optimism, what roles do you think technology will play in the Great Reset initiative led by the World Economic Forum, which is using this pandemic as a rare, narrow window of opportunity to reflect, reimagine, and reset our world to improve the state of the world?
That's a difficult one. Did you say what's the role of tech in doing that?
Correct.
Yeah, I think that's difficult, and maybe, but I think we may have to rethink what technological advancement means, and mass production, consumption. I think it'll be part of the larger global reset in terms of maybe a reduction in consumption and making technological devices at longer life, more reuse, repair, etc.
Yeah,
So
I mean, I think, yeah, go on.
No,
Go
please,
on,
Melanie,
Jamie.
after you.
I didn't have much to say other than I think that, I mean, that's a really big question. But I suspect that the answer for me is going to be that we're not going to. It's not about the question is not going to be answered by thinking about which products or which devices we're going to be able to develop to reset the world or to solve the problems, apart from, of course, the role of vaccines, which is going to be huge. I think alongside that is probably a really significant discussion that needs to be had about both what are we developing technology for, what's the system within which technology exists but also perpetuates, and the key question for me is a proper discussion about who owns the technology and the data inside it. So if we're talking about rebalancing responsibility and addressing fairness, which I think is the underlying theme of these ideas around resetting, then we have to look at power, control, and ownership of the things which are shaping our world at the moment. James.
Yeah, I think I was going to say something similar in that I think the most urgent need is for privacy preserving, track and trace kind of systems, unlike what we've seen maybe proposed and falling apart in some countries. But there's a whole plethora of things that we could do over the longer term, and I think I'm aware of some of those that would apply to the UK. I'm less aware of what's needed elsewhere. So I guess I should go and read the program announcement. So we'll be talking about that later, Fran.
Okay, great. So with that, I know we've run a few minutes over because we've had such a great discussion. So I'd like to say thank you very much to our panelists for their fascinating and thought-provoking contributions. I've certainly enjoyed myself. It's great to hear all these different multidisciplinary conversations and hear how they can all come together for that more equitable society. We'd also like to thank everybody for attending the summit today and for listening to all the talks. If you didn't manage to catch something that you want to, please head to the Summit Rewind section where you can play back some of those sessions. And we would also hope to see you tomorrow between 2 and 6 p.m. BST, where we've got more interesting talks lined up for you on the society theme. And the keynote for tomorrow is our very own Shira, who will be talking more about Data Science Africa. So we really look forward to seeing you tomorrow. Hope you enjoy the rest of your day wherever you are in the world. Thanks very much for joining us.